Hello, today I want to talk to you about the use of ViBE for the gateway and termination market. ViBE is a technology that's a VPN designed specifically for the prioritization of voice traffic. Before we start a demonstration, I just wanted to run you through the key points of ViBE. ViBE delivers incredibly effective header compression, enabling 100 plus calls to be made simultaneously over 1 megabit of bandwidth using G729 as an example. ViBE works with any codec and removes all of the extraneous header information, reducing the size per call in the case of a G729 call from around 43 kilobits per second to 8.1. ViBE can also encrypt all of your traffic throughout the tunnel, ensuring its security. On top of that, ViBE has some unique traffic spreading functionality which allows you to randomly spread your traffic across a range of ports and IP addresses. This is particularly important in some countries where ISPs tend to block traffic. ViBE has inherent features for reducing the latency and jitter of all of the calls going through the links. ViBE has unique quality of service which is patented, which enables us to deliver quality of service at a granularity that other people can't. In addition, ViBE can bond multiple links, has multiple ways of failing over, and provides real-time statistics on the underlying links in use. To discuss ViBE in greater detail, or just to contact us for anything else, please use one of the following methods being shown on your screen. I will show you this again at the end of the demonstration. Let me now show you a demonstration of ViBE. What we have here is emulating a WAN link. On the left hand side we have the LAN link, which is effectively the traffic running into the router before ViBE is enabled when it is enabled. We actually have two WAN pipes to simulate ViBE duplicating traffic through the feature it's got called rain mode. Finally, we have on the right hand side of the top bar we have a link dial to measure data traffic throughput, and the two on the bottom should be self-explanatory: the number of calls that are going through the pipe and also the latency. First of all, let's start a normal data transfer. What this is doing is simulating normal data traffic as you would expect to go through any broadband line connection. You'll see immediately that the data traffic is making the line pretty much unusable for voice. We can get voice calls down there, but the net effect, if you could listen to these calls, would be that they would be horrendous to listen to. Certainly wouldn't be suitable for business use. You see we've got one call going through. We've been saturating the link with data. Let's stop the data transfer and stop the calls and get the gauges back and give them a chance to settle down. Right, now let's enable ViBE. For fairness, let's start the same data transfer. You'll see we're pumping the data traffic across two connections, duplicating it. This has the effect of eradicating any intermittent jitter and latency that might appear on those lines, ensuring that the fastest arriving packets at the remote end get received first, but also it has the effect of 100% resiliency. If one of these lines should fail, the end user will have absolutely no concept of a failure, because everything else will continue on as if it was working totally normally. So you'll see we've got about 500 Ks worth of data traffic being pushed through this line. Let's put 40 calls through at the same time. You'll see the calls building up as they're created. You'll see the bandwidth outside of the ViBE tunnel increasing. We're up to about 1.4, 1.5 megs worth of bandwidth there. And you'll see the most important thing is that the bandwidth inside the two WAN tunnels has hardly increased at all. Okay, we're just over half a meg for 40 calls, with a lot of data traffic being pushed through that link as well. What you'll see is that what ViBE's actually doing is squeezing the data traffic down in order to ensure the voice quality. And you'll see, most importantly, that the latency, the quality of service of those calls and that link is being maintained at all costs. What we can do is to disable and stop the data traffic altogether. And just give that a chance to wind down. It will do in a second. Okay. Let's put another 10 calls through there. What I want to show you is that ViBE is actually now putting 50 calls through in under half a meg. We're just over 400 Ks worth of bandwidth. Okay, so we really can get well over 100 G729 calls in under a meg's worth of bandwidth. Most importantly, what we're doing here is that we're also able to ensure that the quality of these calls is being maintained at all costs. I hope you found that useful. Please contact us for more information.